Hello everyone, welcome back to our college algebra course. Today for this week lecture I'm gonna go over the next two sections of chapter 3. I'll be talking about sections 3.4 and 3.5. So let me start with 3.4. It is about some typical functions and their graph. So in this section I'll show you some typical functions, okay? And then I'll show you the graph and some basic properties of those functions. And I claim we call it typical because for those type of functions, you guys are going to see it quite often during your math courses in the undergrad levels. Okay, so college algebra, pre-calc, calc 1, calc 2, even in trig class, you guys are going to see those type of functions. So it's going to be helpful because when you guys see the function, you kind of right away recognize the type of function and the graph and some basic properties to help you to learn other things quicker. So let's start with 3.4. Some typical functions and the graph. Okay, so let's start with first type of function. F of x equal to square root of x. So first of all, let me show you guys the graph of it. The graph will look like this. Alright, this is the x-axis, and this is the y-axis. The graph starts at 0 and goes to infinity. So whenever you guys have a function, you better start with this domain. You gotta look for the domain of the function. And for college algebra, we learn to find a domain by tracing along the graph. Okay, so it's like by observation. So in here I see what x can start from 0 and go all the way to infinity. So domain is 0 to infinity, and I'm using square bracket because I'm including 0 on the domain. Similarly, when I'm looking for the range, I will still tracing along the graph, but now I'm looking up and down. So it starts 0. Now I'm talking about y value. Okay, y starts from 0 and then keep going up to infinity. So the range is 0 to infinity. All right. Now talk about some properties. Is that how about monotonicity increasing? Yes, it's increasing. And recall what we mean by increasing. The graph is keep going up when you move from left to right. Another word, when you plug in bigger x, you got a bigger y. Okay? Try x equal to 1 and y is 1. X equal to 4, square root of 4, you got y is 2. You plug in bigger x, you got a bigger y. Okay? Domain and range increasing. See what else? Oh, maximum, minimum. Have any maximum and minimum? No max, because the graph keep going up forever. Minimum, yes, it has a minimum right here. And what kind of minimum is that? It's going to be an absolute minimum. So at 0, 0. It means when you plug in x equals 0, you got a minimum y value at 0. This is a minimum point, the point of minimum. Okay? I say it's absolute because it's the lowest point on the entire graph. And it's not the local one because I cannot find any open interval. So that this is the lowest point. Okay? And no symmetry. Symmetry. It's not symmetrical of the y-axis, not symmetrical about the origin. So this graph doesn't have any symmetry on it. Next, let's move on. I'm talking about second type of function. Number 2, f of x equal to x squared. As usual, let me start with the graph. Okay. Graph going to look like this. This is the x-axis, this is the y-axis, the origin is right here. Okay? The domain is all real number, negative to positive infinity, all real numbers. See, if you trace along the graph, it can go freely from negative infinity all the way to positive infinity. What about the range? Now, we see trace along the graph, but we are looking up and down. It could go up forever, right? It's not going down forever. The lowest point you can see is 0. So the range is from 0 to infinity. And again, I'm using square bracket because I'm including point 0 right here. All right? Is that increasing or decreasing? We have both. So the first half of the graph, when x runs from negative infinity to 0, the graph tends to go down. Right? From negative infinity to 0, the graph go down. Go down means decreasing. Okay? For the second half, when x runs from 0 to infinity, 0 right here to infinity, the graph is going up. So you say that the function is increasing. So this is kind of local property. Some interval, the graph is decreasing. Some other interval, the graph is increasing. Again, no maximum because the graph is going up forever. No local, no absolute max. What about minimum? You do have a minimum. The minimum is at 0, 0. And this time, this is both. It is the absolute minimum because this is the lowest point for on the entire graph. Absolute. And it is also the local because I can find the open interval. You see? And we're talking about this little interval right here. This is the lowest point as well. So it's local and local. Okay? Any kind of symmetry? Yes, this side of the graph has a symmetry in here. It is symmetrical about the y-axis. Symmetrical about the y-axis. And if the graph is symmetrical about the y-axis, you say that the function is even. Those two statements are equivalent. Not the same, but equivalent. It means what? Whenever the graph is symmetrical about the y-axis, you can say the function is even. Okay, and vice versa. If you have a function of the a graph of the function. Okay. All right, let's move on to the next function. Function number 3. F of x equal to x cubed. All right, and again, let me show you guys the graph of this one. Okay, this is the x-axis. This is the y-axis. Okay. Origin is right here. Domain, negative infinity to positive infinity. The graph can go freely all the way down, all the way up. Okay. The range, still negative. Oh, domain, talk about left or right. Let's go back a little. Okay. Let's go all the way from the left, all the way from the right. That's what I should say for the domain. And now for the range, go all the way down to up. Right, y value. So still negative to positive infinity. Okay. Increasing, decreasing. The function is increasing all the time. Keep going up forever. Okay? And a maximum, minimum, no max, no mean. Because the graph keep going up forever, going down forever. You don't have any local or absolute max or mean in here. Any kind of symmetry? Yes. This graph is symmetrical with the origin. It means what? Let me use different color. You have a point on the graph, and the point, you flip over the origin, you got another point on the graph. It is symmetrical with the origin. Symmetrical about the origin. Origin. And what does it mean by that in terms of function? You say what the function is R, like what we learned last time. R means symmetrical about the origin. Okay. See? So basically in this section, I'll just show you some typical functions. You see square root, x squared, x cubed, and more, a couple more. Okay, so when you learn it, you see the basic type of function right here. You can roughly sketch a graph and see how it looks like. And some basic properties right here tend to carry over. All right, next one. Graph number 4. F of x equal to q root of x. Okay, let me show you guys the graph of this one. It's gonna look like this. All right. X-axis, y-axis. Okay, the origin is right here. As usual, we start with the domain. Domain is negative infinity to positive infinity, and the range is still negative infinity to positive infinity. That is similar to a function number 3. Increasing, yes. Increasing, still no max, no mean. Okay? It is symmetrical about the origin as well. And the function is still odd. Okay, so let me pause right here for a moment and ask you guys a question for you guys to think of. You guys see that we have two different functions right here. Now, function number 3 and number 4. This is x cubed. This is cube root of x. Carries over all the basic properties. Pretty much the same, right? Right? So the question is, what the difference between the two functions? Okay. We're going to learn more when you guys get to calculus 1. We can talk about concavity, concave up, and concave down. And actually, I claim that those are the inverse of each other. Okay? You guys will learn about the inverse function later on, I think in chapter 6, the last chapter of our course. But for now, my job is to show you some typical function. So for more information, we're going to learn more later on. But at least for now, you see the function. You can roughly sketch a graph of it. Okay, let me move on to the function number 5. We got 1, 2, 3, 4 already. So 5. F of x is 1 over x. Number 5, f of x equal to 1 over x. And start with the graph again. This is the x-axis. This is the y-axis. The function is going to look like this. Two pieces. And then right here. By the way, this graph has a name. It's called hyperbola. The hyperbola. Okay. Start with some basic properties. Start with the domain. Domain is what? We trace along the x-axis. See, there are two pieces, right? It's go from negative infinity, and x getting bigger and bigger, approach 0, but never touches 0, never hit 0. Just jump over 0, keep moving on. So the domain is all real numbers except for 0. And to see right here, 1 over x, right? You can plug in any value for x except for 0, because you know that 1 over 0 is undefined. You cannot have 0 on the denominator. Domain is from negative infinity to 0, parenthesis, union, 0 to infinity. Everything but 0. Okay? Similarly, for the range, now you look at the graph, but you think of up and down. Same idea. From negative infinity, getting closer to 0, never hit 0, and jump over 0 and go to infinity. Negative infinity is 0, union, 0 to infinity. Okay? Domain and range already. Increasing, decreasing. The graph is decreasing all the time. Yeah. That makes sense when we talk about algebra, right? The numerator is 1, fixed. Denominator is x. The bigger the x you plug in, the smaller the fraction is. So bigger x gives you smaller y. Whenever you plug in bigger denominator, you have a smaller fraction. So it's decreasing all the time. Okay? Any maximum, minimum? We have no max, no mean. Let me write up here. No max, no mean. The graph keeps going up forever, keep going down forever. You cannot find the highest point, you cannot find the lowest point. So no max, no mean. Okay, right here. Any kind of symmetry? Yes, the graph is symmetrical about the origin. Okay. You have any point on the graph, you flip over the origin. So the two branches kind of reflect each other from the origin. Okay. Symmetrical about the origin. Another word, f of x is up. Okay. Now let me show you one more property. It's only have in this function so far. Out of 5 functions, this is the only one that has this property. Something called the asymptote. The graph has a vertical line, which the graph is getting closer. There's a vertical line right here, actually the y-axis. The graph is approaching, it's getting closer and closer to the y-axis, never intersect. Same thing, the x-axis right here is another asymptote. What? The graph is getting closer and closer, never intersect. So you have the vertical asymptote. That's the y-axis. Okay, you have the horizontal asymptote, horizontal asymptote, which is the x-axis. All right. Still no max, no min. Okay, let's move on. I'm going to show you one more type of function. Say function number 6. Right here. This is f of x equal to absolute value of x, called the absolute value function. Okay. As usual, I'm going to start with the graph. Graph looks like a letter V. Like that. Okay. X-axis, y-axis, 0 right here. Domain, negative infinity to positive infinity. The range from 0, it's going to be square bracket, 0 to infinity. Okay, domain from negative infinity to positive infinity, all the way from the left, all the way from the right to the right. Range from 0 to infinity. Okay. What else? Domain and range increasing, decreasing. Oh, we got both. First half going down, second half going up. From negative infinity to 0, it's going down, it's decreasing. From 0 to infinity, the graph is going up, it's increasing. Okay. What about, next? Maximum, minimum. It has a minimum right here. It's a minimum. Minimum is at 0, 0. What kind of minimum is this? It is the absolute minimum. Yes, because this is the lowest point. And is it the local minimum? Yes, I can find the interval. The local minimum. It's got both. Okay, so we got minimum, maximum. How about symmetry? Yes, it is symmetrical about the y-axis. So it is symmetrical about the y-axis, and that means the function is even. Okay. So far you guys learned 6 types of function. And by the way, I want you to compare the function number 6 right here with the function number 2, which I erased already. Let me plot the graph, the parabola, and you guys see something similar. The graph, parabola. That's function number 2. Okay, you have this. You have pretty much the same parabola. Domain, negative infinity to positive infinity. The range, 0 to infinity. Decreasing the first half, increasing the second half. Minimum right here. Both absolute and local minimum, right? Symmetrical about the y-axis, so both functions are even. So what's the difference? The difference is the point right here. Okay, the point. Okay, this one they call it a smooth function. Okay, make it like a very smooth turn. This one a very sharp turn. It's not smooth function. Okay, it's just for your information. Okay, just advance. Now let me talk about the very last type of function you see in this section. Okay, and I glad this. At UCF, they talk a lot about this type of function. But we don't talk much in Valencia. It's good to know. So the last time here, it's called the greatest integer function. F of x is denoted this way. Just notation, okay? X and then the square bracket outside. They call it the greatest integer function. Graphically, people call it a step function, and when I graph, you see it. But before I show you the graph, let me just explain how this function works. Okay. As we learned before, the function is like a machine. Whenever you plug in some value, input x, it's gonna follow some rules. It's gonna give you back the output y. Okay. So this function gonna give you back the output is the largest integer, not greater the input. So for sure, for this type of function, the output will be less than or equal to the input. You never get something that bigger than whatever you plug in. Okay? You plug in 5, you get something that 5 or less. Plug in 6.5, you're going to get something that less than equal to 6.5. Okay, and the output got to be integer. So it's two things that you got to know about this type of function for the output. Okay, the output is integers. Okay, and the output is going to be not greater than the input. Two things about the output that you got to know. Output is going to be integer and not greater than inputs. Okay, for example, if you plug in x equal to 5.3, now you have to look for the integer, the output, right? The integer that is smaller than 5.3. We have a lot of integers that's smaller than 5.3. Say 5, 4, 3, 2, 1, 0, -1. Okay, those are the integers, and it's less than 5.3. And among those integers, you choose the biggest one, the largest one. See? Output is the largest integer. That's not greater than the input. Okay? The largest one. So the largest integer that less than 5.3 is 5. Y equal to 5. So this function, you plug in 5.3, you get back 5. Okay. What if I plug in x equal to 5.1? Guess what? I should get back y equal to 5. Because for the integer less than 5.1, I got 5, 4, 3, 2, 1, and among those integers, I choose the biggest one. What if I plug in x equal to 5.9? You know what? I should get back 5. Okay? What if I plug in x equal to 5? You know what? I get back 5 as well. Because say what? Not greater. Okay? I didn't say this cannot be equal. Could be equal. As long as it's not greater. So 5 here is not greater than 5. So it's okay. So the greatest integer is going to give you the same, actually the same output if you put in something like 5 point something. Okay? Alright, similarly, what if I give you x equal to -3.1? Guess what the output going to be? The output going to be an integer, okay? And it's going to be greater than the input, not greater, so it's going to be smaller. You know what you're going to get? It's -4. It's not -3. Why? Because x is -3.1, right? The output going to be integer and smaller than the input. So -3.1, smaller than -3 going to be -4, -5, -6, -7, and among those integers, which is smaller than -3.1, you choose the biggest one, which is -4. Y equal to -4. Okay. So if I plug in say x equal to -3.9, similarly, I still got y equal to -4. Okay. So it's kind of tricky a little if it's the first time you see this type of function, but it's not too hard. After giving examples, hopefully that worked. So let me summarize what we have in here before I show you guys the graph. So say if I plug in anything from how about 2 to 2.9999, so less than 3. Anything is in this interval, so 2, 2.1, 2.2, 2.3, 2.999, I'll get the same output, y equal to 2, right? If I plug in anything from 1, then something less than 2, I always get y equal to 1 coming out. I plug in anything from 0 to less than 1, I always get y equal to 0 come out. You see, x equals 0, 0.1, 0.2, 0.3, I get 0. When I plug in anything from -1 to less than 0, I got y equal to -1 come out. I got anything from -2 all the way to less than -1, I always get y equal to -2 come out. Okay. And let me show you the graph of that thing. So forth and so on. Okay, keep going. And the graph looks like this. x-axis, y-axis. Okay, when x from 2 to 3, 1, 2, 3, 4, 5. From 2 to 3, the output is always 2. 2 including, 3 excluding. You see the way I draw it? I start with first interval right here. When x from 2 to 3, including 2, excluding 3, including 2, excluding 3, I always have the output y equal to 2. Okay? And if I